I love this topic and I can't wait to get going. It's potential dividers, and I know the title sounds a little bit dull, but trust me, once you really truly understand potential dividers, then the whole topic of electricity makes a lot more sense and therefore becomes a lot more interesting. Let's get started. Okay, let's get the basics down before we go too far. In fact, before we get on to potential dividers, let's review what we even mean by potential. I'm going to draw a 6-volt cell. It will be part of a circuit, but for now, I'll just sketch these wires. The wires are full of free charge that flow through the cell. Before they go in the cell, they have no potential energy, but when they come out, they have potential energy. Potential to light up a bulb or something. The potential the charge had was different before and after the cell. That is potential difference. 3 volts. Now I'll draw more circuit with a pair of 10 ohm resistors in series. Kirchhoff told us that the sum of the potential differences will be the total EMF. That means if we put a couple of voltmeters in, that E equals V1 plus V2. Now, here's the clever part. I'm going to put a lamp in parallel with R2 and the voltmeter. What will be the voltage for the lamp? Have a think. Hopefully you spotted that the identical resistors in series would share the 6 volts, so R2 will have 3 volts. Since the lamp is in parallel with R2, that means the lamp will also have 3 volts. By the way, this only works if the lamp has a high resistance. Let me know if you think you know why. So, that's our new circuit. What's clever about it, you could ask? Well, what I'm going to do now is get rid of the first part of the circuit, so I only have this new part remaining. Here on the left of this little circuit, we essentially have a 3-volt power supply. Why am I so excited? I could have just thrown a 3-volt cell in there. It's this over here that's the clever bit. The first bit is the potential divider. What I can do now has so much power. So much power that it will let us build computers and phones. Here's that potential divider circuit again. I've tidied it up so we can change things around more clearly. I have 2 resistors sharing the potential from the battery. Let's make them both 10 ohms like before, and a lamp. The lamp is lit. What I can do now is change this resistor. Let's pick 1 ohm and the light goes dim. Change it again to 100 ohms and the light is really bright. Getting more pro, I can change this to a variable resistor and then slide one way to get a bright light. Slide the other way to get dim. Yep, a dimmer switch. Even more exciting, put in a thermistor, a thermal resistor, and changing the temperature would adjust the lamp. So heating it up made it dimmer. That's interesting. Or I could change to a light dependent resistor, so outside brightness changes the lamp. Okay, so brighter light dimmed the lamp. That's interesting too. Or combine it all together and get some ninja home automation so the lamp comes on if it's hot outside but dark because it's 10 AM and I haven't got up yet and opened the curtains. Whatever we're wanting really, we've now got power to be able to do whatever we want to with these circuits. But that's just the start. With other components like capacitors and transistors, we can really put these potential dividers to work, and that's when we get the Intel and ARM chips that power computers. We'll get to that later. I really hope you see the power of these. We've got a way to control the potential difference around a circuit, to control the EMF. Without this, we'd have to go and physically change the battery, the cell, every single time we wanted to make any changes. Now, you might be thinking, couldn't we just use a variable power supply like we've got in the lab? Well, you could, but how do you think those work? Potential dividers, of course. So take some time, really get to understand these, because if you can understand how potential dividers work, then your understanding of electricity in general will really blossom.